Hello everyone. Today, me and my member would like to share about our project, which is Combinational Logic Design.
Today we will demonstrate our designs for Project 1 titles, the Smart Fire Alarms and Sprinkler Control System. The core problems we are addressing is the risk of the water damage caused by false fire alarm in buildings. To solve this, we design a digital logic circuit that process signal from four discrete inputs. Input A is gas sensors, input B is temperature sensor, input C is carbon dioxide sensor, and input D is a manual override switch. Based on these inputs, our system control two inputs, output X, which is the alarm sirens, and output Y, which is the water sprinklers. Crucially, while the alarm sounds output any detects hazards to warm occupants, the sprinklers is designed with a double confirmations logic, meaning it only activates when both high temperature and carbon dioxide are detected simultaneously or if the manual switch is present. This ensures safety while preventing accidental flooding.
So now there is the basic get in the quarters prime like addition app. We got the four input A, B, C, and D, and to get the output S and Y. To get the output S, we can see from the KMAT output S minimum expression of S equal to D plus BC plus AC plus AB. So we look back to the basic get. The AB is through the AND gate to form AB, and the BC is through the second AND gate to form BC. And lastly, the A and C is through the AND gate to form AC. And lastly, the AB, AC, and BC with the D through the OR gate to form the minimal expression D plus BC plus AC plus AB. For the output Y, also we can see from the KMAT for output Y is equal to D plus ABC. So the D is directly through the OR gate with the ABC, which is A, B, and C to the double AND gate, and lastly through the OR gate to get the final output of Y, which is Y equals to D plus ABC. After that, we can do the simulation for the basic gate. Okay, so there is the simulation of waveform additions. For the basic gate, I already put the input ABCD and the two output S and Y. So as you can see like this. Now I want to do the simulations. Before that, to delete this to avoid the error. And save. After that, we can run. So, as you can see, this is the result for the basic get simulation.
Here I'm showing the NaN configuration, which uses a total of 15 NAND gates. We purposely choose to implement the entire circuit using only NAND gate because NAND gates are generally faster, cheaper, and more efficient to fabricate compared to using different type of gate. To achieve this, we convert all the basic logic gate into NAND-only version. An AND gate can be replaced using two NAND gates. NOT gate can be created using just one NAND gate, and OR gate can be built using three NAND gate. Then we can stimulate the logic gate to check if it produces same result with the basic gate. So we insert the same input like we do in basic gate just now. Then we can run the simulation to check the result. So we get the same final result means that we managed to convert basic gate into NAND gate version. So that's all for our project. Thank you.